Last week, Apple was the most valuable company in the world. This Monday, it was Microsoft. These are two of the most storied names in tech. But now the stock market has a new king, Nvidia, a chip maker based in the US.
Nvidia has just exposed a new computer that sends a chilling message to tech giant Microsoft. The stark warning suggests a shift that could change how we view technology's power. With advanced capabilities, will this be the catalyst for a major upheaval between these technological titans? Join us as we delve deeper into this dramatic development. The last warning to Microsoft's last days. Nvidia unleashes Blackwell. Nvidia has greatly impacted artificial intelligence with its new AI chip. This advanced technology has sparked many discussions among tech leaders about its future influence. Nvidia, originally famous for improving video game graphics, has now become a major player in the tech world, alongside giants like Microsoft, Apple, and Alphabet, with a market value over $2 trillion. The company's value skyrocketed from $1 trillion to $2 trillion in just 8 months due to the high demand for its technology, which is crucial for the AI boom. In March 2022, Nvidia introduced the Hopper architecture, which greatly enhanced the AI accelerators used in data centers. This innovation excited the AI sector. Throughout 2023, as AI became more popular, the demand for Nvidia's products grew, resulting in long wait times of 36 to 52 weeks for H100-based servers. By the third quarter of 2023, Nvidia sold an impressive 500,000 units of the Hopper-based H100 accelerators. This success boosted Nvidia's market value. Building on this, Nvidia introduced the Blackwell architecture, named after David Blackwell, an American mathematician known for his work in game theory, probability, information theory, and statistics, which have all influenced AI design and training. In October 2023, during an investor presentation, Nvidia shared the latest updates in its data center technology, including the B100 and B40 accelerators with the new Blackwell architecture. The shift to Blackwell, previously called Hopper Next, was officially announced at the Graphics Technology Conference on March 18, 2024. The event, held in San Jose's Pro Hockey Arena, attracted over 11,000 attendees, including software developers, tech leaders, and investors. At the conference, Nvidia's CEO Jensen Huang explained that Blackwell is more than just a chip. It's a complete platform that goes beyond traditional GPU production. Blackwell combines 2 dies into 1 unit, working with incredible speed and efficiency, with a communication speed of 10 terabytes per second and no memory or cache issues. Even though some doubted the ambitious goals for Blackwell, Nvidia achieved significant breakthroughs with this innovative chip. Blackwell is designed to work easily with Hopper, allowing for simple upgrades and showing impressive abilities through a prototype board. This board includes 2 Blackwell chips and 4 Blackwell dies connected to a Grace CPU with very fast links, marking a big step forward in computing power. Nvidia also introduced a new feature in its 5th-generation NVLink within the new Transformer engine, doubling the speed of the Hopper, and including computation capabilities within the network itself. This is crucial as it allows multiple GPUs to efficiently share and synchronize information, significantly improving overall performance. Despite its rated speed of 1.8 terabytes per second, the actual performance is much higher, offering much greater speed than Hopper. The new format, called FP6, boosts training performance by 2.5 times per chip, and FP4 doubles the throughput for inference tasks. These improvements are essential for saving energy, reducing network bandwidth, and optimizing time usage, all of which are key for the future of generative AI technology. Nvidia has named this era generative AI, marking a big shift in computing technology, with Nvidia's newly designed processor at its core, featuring the FP4 format that helps generate content tokens. This processor is part of the Nvidia Blackwell AI supercomputer and is 5 times more powerful than its predecessor, Hopper. Nvidia is already planning to develop a bigger and more powerful GPU that will surpass the current model's abilities. The NVLink switch, Nvidia's latest invention, contains 50 billion transistors, almost as many as the entire Hopper chip. Designed with 4 NVLinks, each capable of transferring data at 1.8 terabytes per second. This setup allows all GPUs to work at full capacity at the same time. This leap in computing power gives us a peek into a future where such powerful systems are normal. The journey from the first DGX model to the latest one is a story of incredible growth and ambition. The first DGX-1 model started modestly with 170 teraflops of computing power. Now, Nvidia expects its latest models to achieve 720 petaflops, getting closer to reaching 1 exaflop of processing power within a single machine, a milestone that shows Nvidia's relentless drive for progress. The DGX series by Nvidia is a small but very powerful AI system, capable of processing at exaflop speeds, something usually requiring much larger equipment. It stands out in high-performance computing due to its ability to handle an immense 130 terabytes of data per second with its NVLink spine. This is more data than the total capacity of the internet, showing its impressive processing power. Additionally, it achieves this without costly optical parts, saving on costs and energy. It uses only 20 kilowatts of power, compared to the usual 120 kilowatts needed by similar systems. Its advanced liquid cooling system keeps it at a constant 25 degrees Celsius, ensuring optimal performance even under heavy use. Nvidia's innovation in chip technology continues to revolutionize the AI industry. Nvidia's technology is built around the GPU, a complex piece of machinery. Modern GPUs are incredible, with over 600,000 components and weighing about as much as a large car. These GPUs handle tough computational tasks like training advanced AI models with trillions of parameters. What used to take months and lots of electricity now takes just 90 days with 8,000 GPUs, thanks to the Hopper architecture. The new Blackwell architecture makes this even better, doing the same work with only 2,000 GPUs and much less power, just 4 megawatts. This shows Nvidia's commitment to not just improving, but revolutionizing AI computing. Next, we'll explore the broader implications of Nvidia's advancements as they continue to revolutionize the tech landscape. The rise of Nvidia. Nvidia is expanding into robotics, working on systems that let AI interact with the real world. They're developing tools like the DGX for training AI models and AGX for managing fast sensor data. Nvidia's Omniverse, hosted on Azure Cloud, simulates automated environments where humans and robots work together efficiently. The company is also moving its technology into cars. Soon, their Thor technology will be in vehicles from Mercedes, JLR, and BYD, enhancing robotic systems and possibly leading to humanoid robots. Their big project, Project Groot, focuses on teaching humanoid robots to understand and follow human commands through Isaac Lab, a learning tool that uses Omniverse Isaac Sim for training. Isaac Lab uses Nvidia's Osmos service for tasks on powerful systems, enabling smooth training and simulation for robots. Project Groot allows robots to quickly learn from human examples, improving their ability to interact and perform tasks, from simple gestures like high fives to complex actions, powered by Nvidia's Jetson Thor chips. As humanoid robots get better, Project Groot is leading the way, marking a new era of AI-driven robotics. Nvidia's focus on creating top-notch software and technology sets the stage for a future where robots become important in daily life, changing industries and how we interact with technology. This story shows how Nvidia has become a big player in tech, always pushing the boundaries of what robotics and AI can do. In the 1990s, when technology was basic, 3 engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, had an idea to improve computers. They wanted to make a special chip to help computers handle better graphics, especially for 3D games. Meeting often at a local Denny's, they developed the Graphics Processing Unit, GPU. This chip worked alongside the main computer processor to manage graphics, making computers much better at displaying complex images. This invention started Nvidia's rise as a major tech company, first focused on gaming, seeing it as a promising market. Founded in 1993 in a small condo in Fremont, California, they named the company Nvidia, a mix of NV for next version and Nvidia, the Latin for envy. Their logo's green color symbolized the envy they wanted to create with their powerful computing abilities. Jensen Huang, with his deep tech knowledge, was ready to lead Nvidia to groundbreaking innovations. Nvidia's GPUs revolutionized how personal computers manage graphics, enabling them to smoothly handle advanced graphics. This breakthrough impacted not just gaming, but also video production, scientific research, and professional design. Nvidia's continuous innovation earned it a reputation for advancing technology and improving computer performance. The founders' vision of creating a specialized graphics chip aligned well with the increasing demands of computer users globally, showcasing their forward-thinking approach. In the early 1990s, technology was changing quickly, and in the middle of this exciting time, Nvidia was starting out. Jensen Huang, Chris Malachowski, and Curtis Preem, who had worked at big tech companies like HP, Sun Microsystems, and IBM, founded Nvidia. They knew a lot about technology, but starting a new company was a different kind of challenge, more complicated than the technical problems they were used to. In 1993, Nvidia faced a big turning point. With only $200, the founders knew they needed a formal business plan. Jensen Huang made a bold move by investing his limited money to officially start Nvidia, making sure he got a big ownership stake. This wasn't just about starting a business. It was a crucial gamble in a very competitive field. Finding investors was the next big challenge. They needed to show more than just a good idea. They had to prove they could succeed. Their early attempts to get funding were met with many rejections. In a market full of 89 other hopeful companies, standing out was very hard. But Huang's past connection with LSI Logic helped. He used this connection to get a meeting with Sequoia Capital, a well-known venture firm. Even though Sequoia was skeptical at first, they eventually saw Nvidia's potential and invested $20 million. With their funding, Nvidia developed their first product, the NV1, which launched in 1995. Unlike other products, the NV1 used a quad-based image rendering method, not the usual triangle-based approach. Despite Sega, a major gaming company, preferring the triangle method, Nvidia continued with their quad strategy. They believed it would make game rendering more efficient and lessen the load on CPUs, which was crucial when computing power was limited. As we've seen Nvidia's impact in robotics, let's now turn to how these innovations are paving the way for smarter, safer, autonomous vehicles. Rising from the ashes. Nvidia's goal with quadrangles was to render round objects in games more smoothly and efficiently, considering the technology of that time. The NV1 also had a unique feature. It let users play popular Sega Saturn games on their PCs, mixing console gaming with PC capabilities. But the NV1 faced problems. It was complex and expensive compared to rivals and had trouble with new standards like Microsoft's DirectX, which focused on triangle-based rendering and made graphics development easier for software creators. Despite these challenges, Nvidia persisted and went public in 1999, with its market value jumping to $600 million. Their initial risks and strategic choices paid off. Nvidia's story shows how they navigated early challenges with innovative thinking and determination. It wasn't just about their tech skills. It was their ability to handle financial complexities and make bold decisions that secured their place in the tech industry. The NV1 project was Nvidia's attempt to combine 3D graphics, video, and audio processing into one chip. However, this ended up being more complicated than useful. The chip, like an octopus stretching in many directions, didn't meet customer needs for simpler, more focused devices. This mismatch, along with the rise of DirectX favoring simpler graphics solutions, showed the NV1's limitations. This experience was an important lesson for Nvidia as they adapted to the fast-paced tech world. The NV1 chip's hardware problems caused big financial troubles for Nvidia. One of their main customers, Diamond Multimedia, was very unhappy and sent back almost all of the 250,000 units they bought. This huge return nearly bankrupted Nvidia, leading to layoffs for nearly half of their workers and a financial loss of around $10 million. At the same time, Nvidia was working on another chip, the NV2, for Sega, but it also had the same design problems as the NV1. In this tough situation, Nvidia's CEO, Jensen Huang, took a bold step. He asked Sega's CEO to cancel their NV2 contract, but let Nvidia keep the payments they had already received. Surprisingly, Sega's CEO agreed, giving Nvidia the financial support it needed. This critical help probably saved Nvidia from total failure. The NV1 disaster taught Nvidia an important lesson about listening to customer needs and following industry standards. It showed them the importance of aligning with market demands. With these lessons, Nvidia changed its strategy to develop products that better matched what the market wanted. After the NV1 failure, Nvidia understood the need for simplicity and aligning with market trends in their product development. This change was key to Nvidia's recovery, eventually making them a major player in the PC graphics market. Their journey from the edge of failure to great success shows how resilience and adaptability can help overcome challenges. By the late 1990s, Nvidia not only bounced back, but also made a strong re-entry into the PC market with a clear plan. In 1999, a crucial year when personal computers were becoming common in homes, Nvidia launched the GeForce 256 graphics card. This card was the first to offer programmable graphics, introducing the GPU, Graphics Processing Unit. This innovation greatly improved video game design, allowing for better visuals with advanced shading and lighting, revolutionizing gaming. Nvidia used this breakthrough to go public in the same year, strengthening their market position. By 2000, they landed a $200 million contract with Microsoft to create graphics hardware for the upcoming Xbox console. This deal was a big step up from their earlier projects with Sega, boosting their finances and securing their place in the gaming industry. The Xbox, launched in 2001 with the NV2A chip designed by Nvidia, was a major success. Throughout the 2000s, Nvidia expanded its reach beyond gaming consoles. They became key hardware suppliers for big tech companies like Apple, Dell, and HP, incorporating Nvidia's GPUs into their devices. Each strategic move and technological advance helped Nvidia grow rapidly, turning them into leaders in the tech world. One of Nvidia's smart strategic decisions was to work as a fabless chip company. They designed chips, but outsourced manufacturing to the Taiwan Semiconductor Manufacturing Company. This partnership, lasting over 3 decades, was crucial. TSMC not only made chips for Nvidia, but also helped bring Nvidia's cutting-edge designs to life. By focusing on design and innovation, Nvidia explored new possibilities beyond traditional gaming and graphics. In 2006, Nvidia launched CUDA, a toolkit that changed parallel computing. Before CUDA, programming GPUs was very difficult. CUDA made it easier, allowing developers to use familiar programming languages to harness GPU power. This expanded the use of GPUs beyond graphics to areas like medical research and engineering. CUDA was a significant achievement that showed Nvidia's strategic vision and played a key role in driving the tech industry's evolution. In 2008, the Tokyo Institute of Technology used CUDA-accelerated GPUs for their supercomputer, showcasing its impressive capabilities. This wasn't just a technical achievement, but also a testament to Nvidia's role in shaping the future of technology. Nvidia's introduction of GPUs was a big technical step forward. These graphics processing units became essential tools for many areas like cloud computing, machine learning, and video streaming. Companies like Amazon Web Services, Google Cloud Platform, and Netflix quickly started using these GPUs to improve their technology. In 2012, Nvidia had a big moment when artificial intelligence improved dramatically with AlexNet, a deep learning network developed by Alex Krzyzewski, a PhD student. He used 2 Nvidia GeForce GTX 580 gaming cards to process 1.2 million images, reducing the error rate in image recognition from 25% to 15%. Though these numbers may seem small now, they were revolutionary at the time and changed how people thought about neural networks, which were once viewed skeptically. This wasn't just a tech achievement, It started a new era in AI tools we use today, like ChatGPT, Google Gemini, and Google Lens. The Nvidia GeForce GTX 580 cards played a key role in this change. They were specially designed for CUDA, making them great for running parallel algorithms needed for deep learning tasks like those done by AlexNet. This opened up many possibilities in deep learning, putting Nvidia at the center of this shift. Their investments in CUDA and related software paid off in a big way. Nvidia's GPUs soon became the standard for training and using generative AI and large language models. When ChatGPT launched in November 2022, demand for Nvidia's A100 series GPUs skyrocketed, with big tech companies eager to get these advanced processors. Microsoft, for example, bought an amazing 10,000 units, each costing $110,000. Despite the high price, Nvidia sold hundreds of thousands of these GPUs, greatly boosting their sales. By July 2023, Nvidia's sales had reached $13.5 billion, double the previous year. On May 25th, Nvidia's stock value shot up, gaining $184 billion in just one day. A few days later, on May 30th, 2023, Nvidia hit a major milestone by becoming the sixth company in the world to reach a market value of $1 trillion, later surpassing $2 trillion. This story shows how Nvidia became a leader in technology by introducing new products at the right time and understanding what people need. Nvidia didn't just keep up with trends, they created them. Their ability to turn new ideas into big profits shows they really know how the market works. From being just another company to becoming a top name in the tech world, Nvidia's story is about using smart strategies and innovation to achieve great success. Nvidia's story is a great example of how foresight and innovation can help a company dominate the market. This tale of Nvidia's rise highlights their role in setting tech standards and shows how strategic market positioning can push a company to the top of the global economic stage. Did Nvidia's breakthrough with the Blackwell architecture fundamentally change the tech landscape? Or are we just witnessing another hype cycle? Like and subscribe for more.